Hello, everyone. So I'm doing this tutorial. Actually, basically, the basic idea is to help explain how plotting is done in R, as well as how to make tables. So this is going to be useful for both of the CAs, CA1 and CA2. So what I'm going to do is that I'm just going to do how to do basic simple plots. And I'm going to use this tutorial from W3 Schools, which is basically the same tutorial we were doing 2 weeks ago about our tutorial. And this is just about doing plots. So, and then once I'm done with basic plots, I'm going to do some more advanced plots. So basically what we have is for plotting, what we need is uh, basically the data. First of all, we have to have the data that we want to draw plots about. And then in R, we need to know what kind of functions are going to be used to plot them. So R has built-in functions to do that, and uh, we can use those. So for instance, this is a really basic, simple plot, and this tells us how to plot a point on an XY grid. Just see, for instance, over here, we want to plot 1, 3, whereas the value of x is 1 and value of y is 3 on a two-dimensional two-dimensional plane, which is on the y-axis we have y, and on the x-axis we have 1, and so this is 1 and this is y. So when we call it, so we get this. So if we just try it over here, so this gets us 1 at x is equal to 1 and y. And if we change these values, so we can do, for instance, 1 and 3.5, and it's going to give us a value slightly differently. Um, so yeah, so this is at 1 and this is at 3.5. So this is basically, so basically a point is a basic, the most basic shape. So in any kind of like geometric shapes or any kind of drawing, a point, if we have a pencil, the first thing we learn to do is to draw a point. And for a point to be shown mathematically, we should have to show it on a mathematical rig in which we have kind of like a reference system, in which we have to have a reference point. For instance, this point over here is the 0, 0, which is the reference point, and x is equal to 1 means 1 unit away from here, and y is equal to 3 means 3 units away from here. So this is basically how we draw a point. So similarly, if we have 2 points, for instance, 1, 8 and 3, 10, and if we want to plot them, so this is how we go. 1, 3 is here, and 8, 10 is here, and we just put them in the plot and we do that. If we have multiple points, for instance, so these go as the x values and these go as the y values, and we just plot them. So C 1, 2, 3, 4, 5 are the x values, and C 3, 7, 8, 9, 10, 8, 9, 12 are the corresponding y values. So we plot them here. So we get these values. So this is how we do basically plot points. Similarly, over here, we explicitly specify what the x values are and what the y values are, and we plot x, y. Um, um, for instance, let me try and do this. Similarly, so I'm just trying to see what else I can do with this, something interesting. So instead of providing y as a fixed vector, so this is a vector, C 1, 2, 3, 4, 5, and we had a vector over here as well. So instead of doing that, what I'm doing is that I'd say x times 0.65 plus let's say 64. It is similar to the linear regression problem that we were doing over here. X is this vector, and 0.65 is the slope, and 64 is the intercept, and we plug it in to get a value of y. And let's see what happens over here. So we get this, for instance, so this is what we get. So the plot is something like this. If you see, all the points follow a straight line, and we are going to see how to draw these points or points on a straight line as well in the next section. But this is it. And if you see that if we extrapolate this line to here, it passes the y-axis at a value of 64, which is the intercept, if you see over here. So this is a kind of like a plot of a line, but not explicitly over here, but in the next examples, I'll show you how to do that. So this is, so if we have points 1 to 10, so it is going to plot them just like that over here. And yeah, so if we want to draw a line, so we say, so type is equal to 1. And so we have to specify that the type is going to be equal to 1, and we are going to see how many types we can specify over here. And similarly, if we want to give any labels to our plot, so for instance, this one, main is equal to my graph, tells us that it is going to be the title. XLab is the x-axis label, and YLab is the y-axis label. So when we plot this, we get this as the plot. Okay, and I'm just going to do and we can specify the color of the points that we are drawing. So if we can specify it using col is equal to red, it is going to plot it like that. And we could also, what we could do is that we could change the size of the points using the CEX parameter. So if it is 1, it is going to 1 is the default, by the way, and if you change to 0.5, it is going to make the points look 50% smaller, and 2 means they're going to be 100% larger. So as you see, the points over here are much bigger over here. The circles that represent points are much bigger over here. And similarly, what you can do is that if you don't want the points to be represented by circles, what you can do is that you could specify different shapes. For instance, like PCH 25 gives us shapes of triangles, inverted triangles, and you have all sorts of shapes, and these are the numbers. And you, using the PCH parameter, you can specify any shape. For instance, we could use, for instance, which is the more interesting one from here, maybe I would say 13, let's say. So let me try to do this. PCH is equal to 13, and if I run this, it is going to show it to me as those shapes over here. And if I could make these bigger by using the CEX parameter to 4, it is going to make them 4 times bigger. So these are the points drawn over here now. So this is as simple as that. That the basic idea is that to draw anything, what you need is that you need a function, and the plotting function, and the basic plotting function is plot in R. You can use plot to draw simple kinds of plots. So these are kind of like more plots of lines, and over here you just specify the type is equal to 1, and this is line width. This is basically increasing the width of the line. This is saying 2 means the line is going to be 2 times sharper. So this is basically very, very simple, and you have a lot of options over here to show different kind of things. So this is a different plot in which you're plotting line 1 first, which is C1, 2, 3, 4, 5, 10, and you're plotting a line 2 here using the lines function, which is 2, 5, 7, 8, 9, and 10. So this is as simple as that. I'm just going to move on to how to draw scatter plots, because they're also important plots. And we can use once again the plot function. So we have the values of x are here, 5, 7, 8, blah, 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 and y, our corresponding y values are here. We plot x, y, and we get the scatter plot, how they're scattered on the XY grid, for instance. And similarly, this over here, what you can do is that you can add a title to your plot, and this is the X label and this is the Y label, and you get a plot working. So it is very simple. Um, just give me 1 second. You can do a comparison of plots as well. Uh, So you have two sets of numbers here. So let's say they're coming from two different data sources. So this is for day one, the age and speed of 12 cars, and this is day two, the age and speed of 15 cars. This is the age and this is the speed. This is the age and this is the speed. And what you do is that you plot them using uh, you plot the first set of numbers is using plot, and the second set of numbers on the same plot using points. So you can have them scattered over here. So similarly, if you could have pie charts as well. Pie charts tell us about different, data distribution of data in terms of demographics or in terms of any kind of variables that we'll see an example over here in a while, for instance, and so we did pie charts, and pie charts basically tell us that, okay, what is the percent, for instance, these are the people from a certain state, and they have a certain kind of like proportion of wealth, for instance. So this basically tells us distribution of wealth in 1, 2, 3, 4, uh, let's say counties or provinces, for instance, and this is the blue province, this is the white province, and this is the whatever the light blue, and this is the orange one. And so this is basically telling us, so this is what uh, pie charts basically tell us the distribution of, let's say, resources or any kind of values. So we use pie chart to draw a pie chart. We use the pie function, and this is how we get it done. And similarly, if we have to plot bar charts, for instance, so bar chart is absolutely simple as well. So what you have is that you have X as the, let's say, it could be a categorical variable A, B, C, D, and Y could be corresponding their kind of frequency of occurrence, or for instance, the amount of resource a certain category has, for instance, and we can do a bar plot, and we provide the values of Y over here, and names.arg is equal to X. So names of the different categories are going to be provided by this X vector. And we get this bar plot looking really nice. Okay, and similarly, we can do different kind of bar plots. For instance, over here it is the same kind of bar plot. Only the only thing is that the color of the bars has been changed to red, and you can try other things as well. So this is the density. Density parameter basically tells you that how much you're going to fill a particular bar. So if it is 10, so it is basically, shows you this. So this is pretty much basic plotting in R, how it is done. However, for the purpose of our CA, we are going to try to do some more advanced plotting. First of all, before doing that, I have an example file that I showed you before. However, and I'm going to be working using this. However, first of all, some people had this confusion as to how to do this R notebook. So first of all, I create a new file. Over here, we have different kind of files that we can use. This is R script. This is simple empty file, uh, that can be used to create an R script, which is going to have some code in it that you can run, or you could have the Quarto document. We'll come back to Quarto document next time, but it is not very different to an R notebook. So what we want is an R notebook. So we could create a new R notebook. It creates it over here. It creates some dummy code over here. Over here, you could provide the title, output, and you can also specify some other, for instance, variable names for this as well. I'm not going to be using this because this is an empty R notebook. Instead, I have an R notebook over here that I used for previously. For instance, I just changed the uh, title to this, our CA tutorial. So I just change the title over here, and I can specify author, um, and I can say my name here. Uh, and then, so I can see the visual of this as well over here, for instance, um, I'm gonna have to save this and see why it doesn't show up over here. Otherwise, I'll have to see what it does. Just give me 1 second. Uh, so I have saved it over here in the sample project, and example notebook HTML. Probably this is going to, so you see over here, it really shows the title of this R notebook, and this is the name of the author, and I have some text over here, and then basically it runs down. So I'm not going to, I'll come back to this later on, but first of all, I'll just have to go back and see how it to work with it. So first of all, what I'm going, so I had this code, and I showed it to you previously also when I was trying to do this, explain to you how to work with R notebooks. And I'm just going to start from here. So somebody was asking that how to read this file in. So what I've done is that in the, where I have, this is my sample project that I'm kind of like created to explain this idea of using an R notebook. So I have my R notebook stored over here. So this is has an extension RMD, which is R Markdown. And whenever I save it, for instance, do Control S on this, or let's say I go to File and do a save, it is not showing because already everything is saved, or I could save it as a different file, but I don't need to do that. So, but you could hit the save button, and it is by the way, it is automatically going to store an HTML file with the same file name. And this is what you actually have to do. So that you don't really have to do anything special to create an HTML file, right? So to read the CSV, what I've done is, I'm just going to come back to this, to read the CSV. What I've done is that I have put the CSV file of the CA data in the same folder as my R notebook. Okay, so this is the R Markdown notebook, and this is where I read it. So to read a CSV file, there is a function called read.csv. Okay, and when I do read.csv, participants data final.csv header is equal to true, which means that it is also going to read the column names by as well. And I assign it to a variable called my data. So my data object is going to hold all the data. By the way, it has already been read, and it has been read over here. I showed you previously. So my data is over here. And when I expand it, so it tells me what are the different columns names that are actually present in this uh, uh, in this data object. So what are the column names? So these are the column names that basically arrive from the column names that are present in the CSV file. So it reads every column, and it, against every column name, all the data that is in that column, it puts it against over here. So we have all the participants data. This is participant ID. This is the group which they belong to, whether they're control, cognitive behavioral therapy, or virtual reality based treatment. And this is their gender. This is a demographic variable. And then we have pre-treatment score. That is what was their score before they got any treatment. This is the post-treatment score, and this is the score what they got after they received either the CBT or the VR treatment, and this is basically the change in score. That what was the change in their corresponding score before treatment and after treatment. And this is a very important variable because most of our work is going to revolve around using this. Okay, so now we have the CSV file, and now, for instance, I could, for instance, do any kind of stuff using the data. So my data has everything, and I'm just running this. So it basically returns me the number of rows, uh, and row basically returns the number of rows in the data, which is 200, which basically means that there are 200 data samples. Okay, and the names of my data tells me the names of the columns in the file. So participant ID, group, gender, pre-treatment score, post-treatment score, and change in score. So this is it. So this was just like an example in which I was saying, okay, we do dummy data and assign it a value of 4, and I'm just running it just by the way. Now, if I have to do any kind of plotting, so there is a package in uh, R that is known as ggplot. ggplot, by the way, and ggplot2 is its latest version, right? So I'm going to use this. ggplot basically allows us to do advanced plotting. So basically, the I'm going to tell you about ggplot, or I'm going to say some stuff about ggplot that you can use for any kind of plotting or any kind of package using R. So, and this is another package that uses dplyr. I'm going to run this chunk. So if it runs well, it means there is no problem. It has been loaded. Otherwise, it is going to give me an error, and the error is going to tell me that what is the error. For instance, it could say it couldn't found ggplot. So in that case, if it couldn't found ggplot, you come over here to this pane, and what you do is in the packages pane, what you do is that you hit the install button and you try to find ggplot package. And then from here, what you could do is that you could install it. And this is as simple as that. It is already installed, so I don't have to worry about that. And if there was an error, using DPL, it couldn't find DPLYR, I could say find DPLYR and install it. It is already installed, so I don't have a problem. So uh, that's fine. Okay, so now I'm have to do some plotting, right? And before that, I'm just trying to do some simple calculations on the data. And I'm going to say, I'm just going to change the value of this uh, to, so this is how you specify a header. So, okay, so this is it. I go over here and so it is in the visual mode. It is showing me what the change I made in a nice way. So over here, it shows me that the same change in a raw way. So what I do is that I have to, let's say, calculate the mean, the the average of the change in score. So this is an important statistic that I might definitely we are going to use it in different ways. So how do we compute the mean score? We say we have the mean function. So R is, has a lot of functionality. It gives you functions. You just pass this column into this function, and it is going to compute the mean score for you. And for instance, over here, I want to compute the standard deviation. So what I do is that I do st my data change in score. So it is going to compute the standard deviation. Then I uh, print the values of mean score and standard deviation. So I use the print function. So print is pretty simple. So what I can do, what it shows me is the mean of the change in score, and this shows me the standard deviation of the change in score. Okay. So now let's say I want to plot a histogram. So I should have had a chunk over here, and I don't know. Okay, and this is the basic syntax how to compute a histogram. So it uses the ggplot method. Now we have to look at what ggplot takes as an input. It takes my data, our data, that we had as an argument, and it does calls another function that is known as AES. So if I don't know what, so let's say if I don't know what AES is, I type AES and it basically tells that this is what AES does. It constructs aesthetic mappings. Aesthetic mappings is like how variables in the data are mapped to visual properties. Aesthetics of geoms. Aesthetic mappings can be set in ggplot. Now, okay, so can be a lot of information, but you don't have to worry about. This is what you have to see is that when you call the ggplot, it basically uh, takes in as arguments a bunch of it takes a bunch of arguments as an input, right? So over here, for instance, in ggplot, you specify geom histogram, and I could once again see what geom histogram does. Help geom histogram. So it says histograms. Oh, sorry, histograms and frequency plots. And this is basically for every help, you have this information first, that this is basically the signature of the function, which basically tells us that what input arguments it takes. And this basically tells us that, okay, these are this basically describes what the function does. Visualize the distribution of a single continuous variable by dividing the axis into bins and counting the number of observations in each bin. Histogram, geom histogram display the counts with bars, frequency, polygon, blah, 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 blah. So basically what this function does is that you have to specify the number of bins over here. For instance, over here it is 30, and it's the fill it with light blue. Alpha says 0.7. This is again some parameter. I don't know about it, but it doesn't matter. Color is equal to black, and then stat function is equal to blah, 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 and so these are uh, some statistics it takes for about the data as input. So for instance, I'm providing this as a list. Mean is equal to mean score, standard deviation is equal to ST score, color is equal to red, size is equal to 1. Okay, and then over here I provide labels, which is title, histogram score, normal distribution curve, x is equal to score, and y is equal to density, and theme minimal. So this is it. How now? This can be very overwhelming, that okay, definitely, that okay, how do you know about what kind of inputs to provide, and how, what kind of functions? So the input to ggplot, as you say, the input to ggplot is again a bunch of uh, you know uh, functions. For instance, AES is a function, geo histogram is a function, and so on and so forth. Start function is a function, so it takes arguments as well. So the thing is that you don't have to worry about this. I will tell you how to work with this. For instance, by the way, it has plotted the histogram, and on top of that, it has tried to uh, 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 plot a curve on this using the normal distribution by taking the mean and standard deviation. And this basically tells us that whether the data is actually following a normal distribution or not. So I would say that apart from a few anomalies, it is more or less kind of normal, because of the fact that over here in the center column has a peak, and everything around it is, well, it is not very normal anyway, but I mean, this is what you have to decide in the CA, that does it actually follow a normal distribution or not. So, um, but the crux is that how do you work with ggplot? Now, the thing is that, for instance, if I were to do that, I would look up on the web how to, for instance, plot histograms using ggplot. for instance. And you find a lot of resources over here, right? So histogram and R using ggplot too. So Geek for Geeks is a good website where it has a lot of tutorials, and this basically tells us what a histogram is and what kind of uh, you know uh, what kind of uh, inputs do I have to provide. So for instance, over here you have ggplot, and you provide these uh, input arguments to that, and you work away with the histogram. So this is a really basic histogram which says ggplot df, and df was calculated over here. Okay, so df was calculated over here. Data frame, gender is equal to factor, blah blah blah, average female income, average male income, average male income. So this is basically computing the difference uh, between two data sets corresponding values. So this is basically computing the difference between the two, and it is basically plotting them over here, just like we have the change in score as a DF parameter. Okay, and this is basically, so it calls GUM histogram, and it basically does the plotting. Okay. Uh, So, and this is what you get. So the idea is that not to basically get overwhelmed by what this is going to take as uh, input, but you have to look up on the web as to how to plot this. And this basically plots it for you. So I might come back to this later on as well. So I'm just trying to do another plot, which is like, how to do a box plot. So this is uh, how a box plot can be drawn using ggplot, right? And this basically takes, for instance, uh, uh, the whole data as input, and over here, what you do is that uh, uh, you call the AES, which does the static mapping. So over here, you provide X is equal to group, which is basically the group that basically, in box plot, basically, basically box plot does a plot of whether it is one group or the other group. Over here, you have two groups. One is the control group, and the other one is the VR, treatment group. And over here, as Y, you provide pre-treatment score. You could provide something else as well. So for instance, you could provide post treatment score, sorry, which is one of the columns of the data. And this is how you go with that, you know, uh, box plot. So basically, this basically gives us a trend about, so, or I could have change um, in score. And this is, so this basically tells us the change in score. And this is in terms of the interquartile ranges and medians and stuff. So this is it. Similarly, if I have to do a confidence interval plot, so what I do is that once again, I have to do some calculations on the data, right? Okay, so basically, uh, so this is what we have to learn, that for confidence interval, we have to figure out what our confidence level is and what are going to be our bounds for that. So for instance, if for 95% confidence interval, what we'll have to do is that we have to have on both sides of the normal plot, we have to leave 2.5% each, so that the total comes out to be 5%. So 2.5 we leave on one tail, we leave 2.5%, and the other point we leave 2.5%. So it does that. So this one basically computes the confidence interval using the QT function, which involves the a t based on a t-test, and this is basically DF is computing the degree of freedom, which is n minus 1 into SD, and this is for post-treatment score or under root n, and um, so yeah, so instead of post-treatment score, what I could have is let's say change in score as well as uh, our parameters. So for instance, you'll have to set up the null hypothesis and the alternative hypothesis. The null hypothesis basically says that null means no, that there is no difference between, let's say, in our context, between treatment by one method or the other method. Let's say the null hypothesis means that there is no difference in the scores of CBT after treatment, as well as VR after treatment. So I could use that. I would I use change in score, and over here also I use change in score. Okay, and I provide the mean of change in score as well, which I calculated previously, but you can complete it again. Yeah. So, like you, first of all, for confidence interval plotting, you have to do these calculations, right? And you have to you have to provide this information first, okay? And then what you do is that you do the so you created a CI data frame, okay? And in that frame, you took these values. Took value from my data, and you said you group it by group, and then you summarize mean score is equal to change in score. CI lower bound is mean score minus QT 0.75 DF and minus 1 into SD, and change in score divided by square root of n, right? And CI upper is equal to mean score plus QT 0.975 degree freedom and minus 1 into SD change in score is divided by SQRT over n. So these are basically formulas that we actually also get from our lecture notes as well, that how they are basically they're computing t values as well as or T scores, for instance, as well as standard errors corresponding with the T distribution. Okay, and now when we have to plot confidence interval, we use this CI data and we pass it to the ggplot parameter, the ggplot function, and to the AES function we provide x is equal to group, y is equal to mean score, and you say you provide these geom bar and geom error bar to these functions. You provide values. Now the thing is, and once again over here we have labels and this and these kind of things. So what we are going to do now, I'm going to do now is that I'm going to hit the run button. It is going to compute it slightly differently, and it is going to be like this. For instance, the confidence interval scores are over here. Okay, now the question is that once again that this can be very overwhelming, right? Now, how do you figure out then how to do a confidence interval score? The idea is to look once again on the web that how to do a confidence interval score using ggplot. And yeah, so I have it here already, yeah. So this is this is a nice tutorial. Basically, this tells us that, okay, what kind of stuff that we need from the uh, uh, to input to the so for instance over here, this is, given the data, it takes the data as input, and it does these computes these lower and upper bounds, and for the data, okay, and this assigns the result to GFG variable, okay, and then it just simply calls ggplot, and then over here um, it plots that as a result. For instance, uh, what I could do is that um, I could use this instead, but this is basically, I'll have to do some editing to this, but to provide to that the change in score column as an input over here to this. So this is basically it, that for every function that you have to draw, uh, and this is another method that basically tells you how to plot confidence interval using a plot CI method. Uh, Plot CI function. And this is basically requires you to install the Plotrix package. I'm not going to go into this. I'd say just stick with the ggplot for now, and try to see how to plot stuff using the ggplot function. Okay, uh, so it is as simple as that. So what you get is you can get all sorts of plots using the ggplot function. Now let's try to see how to draw a table. So how to draw a table? It is very simple. First of all, we have to figure out what kind of table that we need. Okay, so this is a table that is basically corresponds with one of the the tables that are mentioned in the handout that I gave with that. So basically what it does is that look into the table that, okay, what kind of data do you need? So what it does is that it takes the my data and computes those parameters that I need to basically show in the table and assigns them to the result summary variable. Okay, so this is doing group by group, which means the control group or the VR group, and says summarize. It calls summarize, and it says for pre-treatment mean is equal to mean of pre-treatment score, pre-treatment SD is equal to SD, standard deviation of pre-treatment score, post-treatment mean is equal to mean of post-treatment score, post-treatment SD is equal to SD post-treatment score, and mean change is equal to mean post-treatment score minus uh, pre-treatment score. Okay. Uh, yeah, and it basically it does that. Or otherwise, what I could do is that I could basically omit this, and I could say I do already have this change in score. So it computes the mean change. Okay, and SD change as well, I could simplify this by saying use instead change in score. So that's it. We get it. Now the thing is that we hit the run button, run this chunk, and we get the results now in result summary. Now the thing is, now we have to show this. We have to show this. So what can we do with this is that we add a new chunk, and I'm going to show you two methods as to how to show this. So one is by using the print method, and I say in the print method, I call result summary, right? And I show it, and it shows me this results over here. Now, what I could do additionally is, so this extends to over here. So this is kind of like a table. It's not a very nice one, right? It is a bit short, but I would run the save button and try to see how does it look like in the HTML, for instance. Uh, so it doesn't show it over here, but I'm going to see how it shows it. But let me first of all try to show you how there is an alternative way for showing tables that are better than looking at this. So this one involves using the print function, and it doesn't create really beautiful tables. So if you want to draw beautiful tables, what you're going to need is another package which is known as Cable Extra. Now the Cable Extra, so what I do is that I'm just only loading the package library Cable Extra, and before that I have to load some other libraries as well, NetR, TidyR, DPLYR. These ones, some of these are installed, some of these are not. It doesn't matter. When we are going to hit the run button, so it is going to tell us as an error if it does not find a package. It's going to say, oh, I couldn't find the Cable Extra package. And what you do is that you go over here and install this package. So you see Cable Extra, it is, you do this and you can hit the install button and it is going to install that. I've already installed that, so I'm not going to go into that. And so once I have this installed, what I do is that I call this cable method function, and to this I pass the result summary. So the result summary is the same variable that basically had our results computed, that we computed using this uh, this chunk. Okay, so it has it already, right? And I pass it result summary, and I give a caption result summary table, and I'd say uh, another parameter which is cable styling. Okay, now when I run it, so it shows me in a really neat and clean way the results table. Okay, so this is how it looks. I'm just going to expand it a little bit just so that it looks, just to see how it looks over here. Uh, so this is how it looks over here, and what I can do is I can expand a little bit more just for the purpose of readability. And so this is how it looks. And what I could do is that I could scroll it to the right to see how everything over here looks. So when I'm going to close this right now, and if I have another one open, I'm going to close that too and see. I save it, and I'm going to see how this one looks now. Yeah. So this is the result of the print. Uh, um, Called the print function. So this shows us over here the table. It is not so, it's not too bad either. It just has these you kind of like tags over here. So maybe you just don't find them really good, but it is up to you, whatever you like. But cable is much better. It shows the results in a really nice way over here. So this is pretty much all what you have to do to draw different kinds of tables and plots in that. Now the question is that how to, for instance, make this. This is very simple. You go to the, for instance, um, uh, I'm going to go to the, sorry, uh, oh sorry, this is a big one. I'm just going to open this. So for instance, this is this is the table that this is the document that I gave you to, for instance, uh, figure out how to plot these, what kind of tables to plot. So you could basically, when you're writing this result summary, what you could do is that when you're creating this result summary, you have to look at what kind of data is requested in that table. So it says pre-treatment mean uh, uh, so it says for instance, over here, if I look, just let me see what other kinds of tables you have. So uh, so this basically is, you know, all the data that we need over here. So it is, you know, you can compute. So for instance, let's try to do this table, for instance, that what is going to be the frequency of depression severity table. So, or for instance, this one. I just want to do a table that is simple enough. Just by the way, I chose the wrong table, I think. Uh, and so let me try to figure out which table it was. Pre-treatment mean, pre-treatment SD. Okay. Uh, post-treatment mean, post-treatment SD. Uh, and this is basically mean change, and this is basically what it shows. So I'm just trying to figure out that which table, which uh, um, I think this is the one, or this is just one of the tables anyway that I'm showing over here. But whatever you have to compute, so this one shows, you know, pre-treatment mean, post-treatment mean, pre-treatment ST, post-treatment ST, and you can provide it over here as arguments, right? You can compute them here within the summarize block. So you say group by group, summarize, and within the summarize, what you do is that you compute these things. So if you want to show pre-treatment mean, compute pre-treatment mean. If you want to compute pre-treatment ST, compute pre-treatment ST. If you want to compute post-treatment mean, compute post-treatment mean using the mean function. And if you want to compute post-treatment ST, you can compute post-treatment ST. And once you have created the summary table, you know, the summary object, what you can do is that you can either call the print or you can call the cable function to show the results. So this is pretty much all I have to say. I can't explain, I can't do everything, you know, because that will be a little bit of that will be problematic, because I have to leave for you guys to try to do something as well. So basically, if you had to do this confidence interval for means, for mean changes table, so what you could do is that uh, you could create a summary, you know, summary object by using the summarize function, and in that you compute these control CVD for the mean change, for the control CVD for, and then 95% confidence interval lower is using the Z score, you know, the Z distribution or the T distribution, and then you can do it using the 95 confidence interval upper using the Z distribution or the T distribution, and you can plot that. So it is as simple as that. So by the way, having said this, you know, the idea is not to in the report, the idea is not to just show the plots, but or tables. But the idea is to use these plots and tables to basically analyze your data. And first of all, you analyze the data. That what are the trends in the data? Does the data basically follow a normal distribution or not? If it is large enough, or if it is large enough, what kind of test are you going to do? Either you're going to compute confidence intervals using Z's test, or you're going to compute them using the T test, and you have to set up a hypothesis test. Hypothesis test is very simple. In your null hypothesis is going to say that your change in score, there is no change in score between both groups after treatment, right? And the alternate hypothesis is that there is a change, right? And so this is the minimal, you know, the kind of like the least that you can do, that you can base your your hypothesis test on this, and then whatever you found, whether you find that you can do it using the standard normal distribution using z-scores and z-tables, or the z-test, or whether you can do it using a t-test. So this is pretty much all I have to say for now. I don't know if you have any questions, so you can basically ask those questions to me later on. So I'm just going to stop it now for now.